Alright, so here we go. We're at 8:25:20, and we're going to be solving more equations. And what I'm going to try to do to help myself and you stay a little bit more organized is we're going to call this 8:25:20 and we're going to call this A. Because we're going to try to split the class each day into two sections, two sets of notes. So the A notes would be the beginning, B notes would be the second part of class. When I upload each set of notes to YouTube, I'll do it as 8:25:20 Algebra 2 A, and then 8:25:20 Algebra 2 B, and that's what everything means. So we're going to move along here. We're going to be solving these multi-step or two-step equations, and we're going to add some other operations. So right here we got if 5 is equal to t divided by 2 minus 3. Okay, just like yesterday, when you're solving equations, you're always trying to get the variables by themselves. Alright? So in this case right now, you're going to try to get this by itself on one side of the equal sign. So you would add 3 to each side, right? So if you add 3 to the right and you add 3 to the left. Then on the left-hand side, we get an 8. And 8 is equal to t divided by 2. Now, there's an operation in math that's called the inverse operation. It's a fancy term for doing the opposite of. This t right now is being divided by 2, isn't it? What's the opposite of dividing by 2? To multiply by 2. So right now, to solve for t, if we multiply both sides of this equation by 2, then on the left-hand side, we get 2 times 8, which is 16. On the right-hand side, the 2 that's in the denominator that's being multiplied by 2 over 1, this all cancels out. And all that's left is t. And t is equal to 16. Alright, so if we had one that looked like, let's say that it was 3 plus a over 5 equals negative 2. We're trying to get to a over 5 by itself. So this 3 on the left is positive, so we can subtract 3 from each side. These 3's cancel out, right? And this a over 5 drops down, so we get a over 5 is equal to negative 2 minus 3. Negative 5, good. Did anybody order the calculator that I asked you to get? One person, all right. 2? Nice, thank you. Oh, you've got one, good, good. Anybody else have a calculator other than their phone? Good, good, good. All right, I would suggest you get one. I would highly recommend you get one. Get a calculator that's not your phone, please. Pretty please. Okay, so look, at this problem on the left, when t was over 2, we multiplied both sides by 2, right? So if a is over 5, we're gonna multiply both sides by 5. The 5's will cancel. And the a is going to be equal to negative 5 times 5. Negative 25. Boom. Done. Can you handle that? Let's do one more. Let's do something like 12 equals x over 4 minus 7. So again, we're isolating the variable. We're getting it by itself, so we're going to add 7 to each side. And 12 plus 7 is 19. And 19 is equal to x over 4. So if 19 is equal to x over 4, or if 19 is equal to x divided by 4, well then we multiply both sides by 4. And 19 times 4, I'm going to verify that with a calculator. I get 76. 76 is equal to, on the right hand side, the 4's cancel out, and we bring down the x. So 76 is equal to x. You guys good with those? Okay, so let me move along and let me show you an example of the other type of problem we're going to do in the first part of class here. So now let's take something like, let's take y minus 6. It's divided by 3. And all of that is equal to 10. Now, do you see how this looks a little bit different? Okay? Right up here, in this first example we did, the t was by itself, wasn't it? And the a was by itself. And then the x was by itself. But now the y isn't by itself, is it? The y has a minus 6 attached to it. Come on, baby. What the? Oh, there. This is y minus 6 divided by 3. So that y minus 6 has to stay together. Okay? So look, the first thing you do is you get rid of this 3 in the denominator. How did we get rid of this 4 in the denominator over here? We multiplied by 4, right? So how are we going to get rid of this 3? We're going to multiply by 3. So if we multiply both sides of this equation by 3, these go away. And the whole y minus 6 comes down. So we got y minus 6 is equal to 30. And now it's simple. It's what you did when you first started learning how to solve an equation, right? So we do the opposite of what they're doing to the variable. So we add 6 to each side. These cancel. And what's y equal to? 36. Let's take a look at negative 3, or let's go negative 4 equals d minus 6 over 5. So we're trying to get the d minus 6 by itself first, right? So we're going to do what? We're going to multiply both sides by 5. On the left, we got 5 times negative 4, which is a negative 20. On the right-hand side, we multiplied by positive 5 to get rid of these, or to make them cancel out. So we drop down the d minus 6. And if we're subtracting from the variable, the inverse operation would be to add. So if we add 6 to each side, negative 20 plus 6, negative 14 equals d. Any problems or questions? Yes. What's that? Any problems or questions? All right. So here's some practice problems. Don't write. Sorry about that. We're not going to do that one. 8, yeah, just erase 8 for now. I'm going to put a different one up there. Alright, go ahead and work those out, please, and we'll get back together here shortly.